At the end of the last century, a comet captured into orbit around a planet traveled too close and was shredded by its gravity into multiple pieces, some as large as a half-mile long. We are talking about Comet Shoemaker-Levy 9, which had one of the most spectacular endings ever witnessed by humans. Several months after its discovery, fragments of the comet collided with Jupiter. Scars from the collision were visible from Earth. Today, we are going to see the damages caused by this comet to Jupiter, and how Shoemaker-Levy 9 got its name. Stay tuned because this is just the beginning.
Audio Jungle.
The comet was named after its discoverers. Comet Shoemaker-Levy 9 was the 9th short periodic comet discovered by Eugene and Caroline Shoemaker and David Levy. When Comet Shoemaker-Levy 9 was discovered in 1993, it had already been destroyed into more than 20 pieces and was orbiting Jupiter in a 2-year orbit. Further observations revealed that the comet, which was thought to be a single body at the time, had made a close approach to Jupiter in July 1992 and had been torn apart by tidal forces caused by the planet's powerful gravity. The comet was thought to have orbited Jupiter for about a decade before collapsing. The fragmentation of a comet into multiple fragments was unusual, and observing a captured comet in orbit around Jupiter was even more unusual. But the biggest and rarest revelation was that the fragments were going to smash into Jupiter. While the impact was powerful, it was more than just a show. It provided scientists with an opportunity to learn more about Jupiter, Shoemaker-Levy 9, and cosmic collisions in general. The composition and structure of the comet were deduced by researchers. The collision also caused dust to float on top of Jupiter's clouds. NASA had spacecraft in position to witness a collision between two bodies in the solar system for the first time in history. As the string of fragments labeled A through W smashed into Jupiter's cloud tops, NASA's Galileo orbiter, which was still en route to Jupiter at the time, captured unprecedented direct views. The effects began on July 16, 1994 and lasted until July 22, 1994. So, what did scientists learn about Jupiter as a result of the impacts? For one thing, the dark clouds of impact debris acted as tracers of the winds in Jupiter's stratosphere, and scientists were able to measure those high-altitude winds by tracking their motion over time. Temporary changes in Jupiter's aurora revealed to scientists that the impacts influenced Jupiter's magnetosphere. According to scientists, the comet was originally 0.9 to 1.2 miles, 1.5 to 2 kilometers wide. A similar-sized object colliding with Earth would be disastrous. The impact could propel dust and debris into the atmosphere, causing a haze that would cool the atmosphere and absorb sunlight, enveloping the entire planet in darkness. If the haze lasted long enough, plant life would perish, as would the people and animals who rely on it for survival. For weeks, astronomers studied the SL9 impact and its aftermath on Jupiter. However, the chemical impact of SL9 on Jupiter's atmosphere lasted much longer. Comets are frozen bodies. During the fireball phase of the SL9 impacts, scientists observed water vapor emission. Later in 1997, the ESA Infrared Space Observatory discovered water vapor in Jupiter's stratosphere. At the time, astronomers suspected that it was the result of the SL9 impact, because comets are water-rich bodies. However, there were other possibilities for the observed water, such as interplanetary dust particles produced by cometary activity and asteroid collisions, estimated to have weighed only 24 pounds and measured only 5.5 inches in length. Aside from Shoemaker-Levy 9, the only other impact that left a scar in Jupiter's clouds occurred on July 19, 2009. No one saw the flash or the impact in this case. The impact could have happened on Jupiter's backside. Witnesses only saw a dark gash caused by an impacting object. On April 10, 2020, the Juno spacecraft team detected an impact of a small object on Jupiter's night side. The team estimated the object's diameter to be 3 to 13 feet, 1 to 4 meters. The remaining impacts were discovered by amateur astronomers. Each appeared as a brief flash lasting 1 to 4 seconds. Only one, the 2012 impact, was visually observed. The rest were captured using astro imaging. Comets and asteroids strike Jupiter more frequently than the average planet. It is larger and has a larger surface area than any other planet. But the main reason is that it has massive gravity. It's also in a region of the solar system where asteroids and comets move slowly. This gives Jupiter enough time to prepare them for a hard landing. You may think that an automated telescope can image Jupiter for thousands of hours per year. However, this is not as simple as it appears. If we can only image Jupiter when the sky is dark, Jupiter is at least 20 degrees above the horizon, the sky is clear, and the air is steady, then we're only imaging Jupiter 10% to 15% of the time. This equates to no more than 1,000 hours per year. Nonetheless, it only takes 5 seconds to record an impact, so go for it. The impact of Comet Shoemaker-Levy 9 on Jupiter in July 1994 left an indelible mark. Asteroids and comets continue to strike Jupiter, the largest planet in our solar system. Let's see what new things we get in the future. With this, we come to the end of the video. Thanks for watching. See you in the next video.